We are told that delta G or Gibbs free energy should be less than zero for reaction to be spontaneous. And this does not make sense intuitively. How can free energy be less than zero? And how can a reaction proceed spontaneously if the energy is less than zero? So we go ahead and explore this question. So we consider this reaction where methane is combusted, and this is an exothermic reaction, and we know that heat is released in the reaction. However, we write delta H as minus 890 kilojoules here on the product side. And what it really means is that the energy of the reactants have been reduced by 890 kilojoules in the process of heat release. So it's a sign convention which specifies the reduction in energy of the reactants. So we explore this further. So we consider the heat of formation of the various reactants and the products. And here we will see that the energy of CH4 is much higher compared to carbon dioxide and water. So although we have traditionally we would be required to find the heat of the reaction as sigma products minus sigma reactants, I have done it the other way around. I have done it as sigma reactants minus the sigma product. And this shows that the heat released is 890 kilojoules. So the heat released is 890 kilojoules, and it is represented as a change in enthalpy as minus 890 kilojoules. And this is a sign convention. This is how it is represented. Here delta H provides the useful energy, and T delta S is the energy loss due to disorder or entropy. And this can be imagined like an incline with a block, and the block has some potential energy, but it is also restricted because of friction. So when the useful energy is more than the frictional force or the frictional energy, the block will move down spontaneously. And similarly in reactions, if the useful energy is more than the energy loss due to entropy, the reactions will be spontaneous. And it so happens that because of sign convention, delta H and delta G are supposed to be negative for reactions to be spontaneous. So I hope you found this video useful, and thanks for watching.